Hello students, in this video I'll be explaining on the structure and classification of amines. Now firstly, structure. Now in the structure of amine, the most important point is that amines are derivatives of ammonia, and the central metal atom is amines are the derivatives of ammonia, that is amines. Now in amines, like in ammonia, we have the central metal atom is nitrogen. Now here the central metal atom is nitrogen. Now let us check first the hybridization. According to hybridization, now the definition of hybridization is bond pair plus lone pair. We get the hybridization. Now bond pair is how many atoms are attached to the central metal atom. That means how many atoms are attached to the central bond pair. Okay, let me write it here. How many atoms attach to the central metal atom, that is nitrogen. And then lone pair is how many lone pairs remain after forming bond pairs. Now from the definition of hybridization, we have here bond pair plus lone pair, we get hybridization. Now let us check for ammonia amine molecule R and H2. Now we see here that in nitrogen one lone pair, 3 bonds, one H and H. Now 3 bonds are formed by ammonia, the central metal atom, 3 bonds and 1 lone pair. In the same case for the secondary amines, 2 atoms and then 1 hydrogen. The hydrogen here, 3 bonds, 3 bond pairs, and the nitrogen has 1 lone pair. And in the same case for tertiary amines, nitrogen would have 1 lone pair left after forming 3 bond pairs. Now 3 bond pairs are formed and 1 lone pair. Now we get the hybridization. Therefore at the hybridization we get how many bond pairs we have? 1, 2, 3. Here also we have 1 bond formed by hydrogen, 2 and 3. Here also 1, 2, 3. Now 3 bond pairs plus how many lone pair? In primary amine we have here 1 lone pair. Even in secondary we have 1 lone pair. In tertiary also we have 1 lone pair. That means the sum is 4. Therefore this shows that this is sp3 hybridized. The nitrogen atom is sp3 hybridized. Now according to sp3 hybridization, the structure, according to this sp3 hybridization, the structure should be tetrahedral. But it is not possible when we have lone pairs. So when lone pair is present, tetrahedral structure cannot be formed. And so in the case of amines, we have here amines, nitrogen, a pyramidal structure is formed, like a pyramidal structure. A pyramidal structure is formed. Now we have the ammonia molecule. So according to hybridization, nitrogen has 4 sp3 hybridized. It is arranged, the 4 sp3 hybridized orbitals are arranged in an tetrahedral manner. sp3 hybridized, sp3. Now the lone pairs occupy this position, and then the 3 bonds are here. it is known to us that in tetrahedral structure the bond angle is 109.28 degree. However, in the case of amines, due to lone pair, this is the lone pair and bond pairs, lone pair to bond pair repulsion, the pyramidal angle becomes less, and it has a pyramidal angle of 108 degree. Therefore, to summarize, we can say that the most important point in amines is that the central metal atom is nitrogen, which is sp3 hybridized. The central metal atom has orbitals which is sp3 hybridized, and the bond angle is 108 degree with a pyramidal structure. Since lone pairs are present in amines, the trihedral structure is not possible, and it forms a pyramidal structure. So now let us move to classification of amines. Amines are generally classified as primary, secondary, and tertiary amines. This classification is the same for both alkyl amines and aryl amines. Now for primary amines, secondary amines, and tertiary amines. Now the amines are so called as primary amines when only one hydrogen atom is replaced. For example, only one hydrogen atom is replaced in ammonia. That means we have when one alkyl group replaces one hydrogen atom. For example, we have the symbol. This is a simple amine. This is an alkyl amine, primary alkyl amine, and primary aryl amine would be this. Now secondary amines when two hydrogen atom is replaced. Therefore the structure would be such as NHR. Example, we have here CH3 NH CH3. This is secondary alkyl amine, and in the case of aryl amines it would be NH replace two hydrogen atoms replaced by two aryl atoms. Now the tertiary amines when all the three hydrogen atoms are replaced. Therefore we would get it as nitrogen. All the three hydrogen atoms are replaced. For example, we have nitrogen, CH3, 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 or aryl, tertiary aryl amines. So this is the classification for alkyl amines and aryl amines. Also to keep in mind, the second alkyl group may be the same as in this case or may be different. For example, like we have our CH3NH or C2H5. The second alkyl group, that is the second alkyl group or the aryl group, may be simple or different. And also amines may be said to be simple or mixed amines. Now when simple means when the alkyl or the aryl groups are the same, as in this case when the alkyl or the aryl groups are the same, and mixed means when the substituents, when the alkyl or the aryl groups are different, as in this case.